Hello there. So now what we're going to do is look at the examples for adding and subtracting surds. So this isn't as hard as it might appear at first. So let's work through these examples. So for A, we have 3 times square root 5 plus 4 times square root 5. So altogether we have 3 of this thing plus 4 of this thing. That means 7 of that thing, right? So what I want you to do is think of this like expanding. So another way we expand is we take the common thing, which is square root 5, outside of a bracket, 3 plus 4. So that means 7 times square root 5. And we always put 7 first and beside it square root 5. And there is an implied multiplication in between the 7, between these things here. But you don't have to put a dot or a times. There's a little red light dot for you. Okay, next one over, we have 2 by square root 2 plus 1 of square root 2, right? There's no 1 in front of it, but that's the imaginary, minus 3 lots of square root 2. So the things, the lots of square root 2 is all the same in each of those 3 terms. We have 3 terms. We're adding 2 and subtracting 1 of those terms. All of them have an amount of square root 2. So actually we have 2 of them plus 1 of them, take 3 of them. So actually we have 0 of them by the time we do all that. 0 lots of square root 2. Another way to do it, if you want to do the factorizing, formal factorizing that we did in part A, we're taking out square root 2, and in the brackets we have the uncommon factor, 2 for that one. For the second term, once we've taken out square root 2 to the front of the brackets, we have plus 1 of them, and third term 3, which is square root 2 times 0, which is 0. So that one reduces right away. So this here, 0 times square root 2 is also 0. Okay, for the third example, we notice a couple of things here. There's 3 terms, I guess is something we notice. 2 of them are the same, so the first and the last term are on the basis of half root 7. The term in the middle is half root or square root 3, so it's not that helpful, and we also have 2 lots of that in the front. So we can't really do anything with that in terms of adding or subtracting it. So what we're going to do instead is just kind of park that one out to the side. So 2 lots of square root 3. With the other 2 terms, they're on the basis of square root 7, and we have 3 lots of them minus 1 lot of them. So actually 2 lots of square root 7 plus that. And that's about as far as we can get with that, if you like. And it's exactly what your book has come to also. Okay, for the next wee set that goes with the harder questions, we have some surds with unlike surds. And so what we have to do is we have to expand these out a little and see if we can then find some common factors. So 12 is made up of 2 times 6. Let me stitch to the side. 12, oops, skinny pen. Okay, 12 is 2 lots of 6. It's also 3 lots of 4. And 75, we can do 3 lots of 25. So I can see 3 is a common factor of both. So let's use 3 times 4 for this one. Now make sure the surd sign goes all the way across the 3 and the 4, multiplied by 3 times 25. This guy here, we can split that up as to square root 3 times square root 4. And there should be plus. And we're adding that to square root 3 times square root 25. If we look again across this expression, so what we've done is expanded each of those expressions out. If we look across, we have the common factor of 3, which comes out of our bracket so that we can put the rest of it in there. Square root 4 plus square root 25. So the reason I'm plussing in the middle is I'm paying homage to the plus here. And when we factorize, that is also what we do, okay? So that when we expand this guy back out, this thing, square root 3 times square root 4, that, plus square root 3 times square root 25, all this plus in the middle. Okay, so let's follow this one through because we seem to be onto something. Square root 3, now the thing in the bracket, square root 4 is 2, and square root 5 is 5, because 5 5s are 25, and 2 2s are 4. So 2 plus 5 is 7, so I'm going to put 7 to the front times square root 3. The reason I'm just going ahead and putting these equals is because we are following some kind of working through here, and we're just equating that line by line is the same thing. So all of this follows through line by line to our final answer. Okay, so the equals is just a systematic way of working. Let's look now at part B example and see if we can find some commonalities. Okay, so for part B, I have here 3 terms, and I need to look inside them to see what the commonalities are. I look inside the surd terms, inside the surd signs. 18 is comprised of 9 times 2, or 3 times 6 is 18. 45, 9 times 5 are the factors, and 50, 2 times 10, that's not right, 5 times 10 is 50, or 2 times 25. So I haven't got one common factor that appears across the 3 terms, none of those. 5 appears in the second one and also in the last one, but not in the first one. So we're just going to have to break this down as best we can. What we're going to do is 2 times square root 18. I think that we can replace square root 18 by 2 times 9. I'm going with that one. 2 is irrational, so it's not going to square down. However, watch this. The 9 is really helpful to us. Okay, so I'm just going to park that there for a moment and look at the next 2 expressions and what are we going to put in the bracket. So for the second one, I'm going to put in, to replace 45, 9 times 5. I'm liking the 9 in there because I know square root 9 is 3, and I'm subtracting away. Now I'm going to use 2 times 25. 2 is a smaller prime number than 5, and 25 square roots down. Okay, so when I look at those expressions, the first one is 2 times square root 2 times 3, which is square root 9, okay. Square root 2 times square root 9. The second one is square root 9, which is 3 times square root 5. And the last expression is, I'm just going to do it bits by bits, just a little bit above, square root 2 times square root 25. Square root 2 times 5, okay, because square root 25 is 5. When I look across these 3 expressions here, what I can do for the first one is take that 2 times 3 is 6 out to the front, times square root 2, plus 3 times square root 5, minus square root, oh, my bad, I should have put the 5 first, minus 5 lots of square root 2. Looking across, it's a little bit different to what I was expecting. I thought these 2 would have more commonalities, but once we've reduced that down, it's the first and the third term. So I have 6 lots of square root 2, take 5 lots of square root 2, leaves us just 1 lot of square root 2. So that's factorizing those 2 out again. We're going to end up with just square root 2, 1 lot of square root 2, plus 3 times square root 5. 5 is irrational, 2 is irrational, or square root 2 is, and 5. So we can just leave that like that. So that's going to be our final answer.